Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is 4th June 2025. This is an article published in Nature Medicine online, open access, individual variations in glycemic response to carbohydrates and underlying metabolic physiology, from Michael Snyder's group at Stanford. 1/3 of US adults have prediabetes. 70% progress to type 2 diabetes. Postprandial glycemic response predict cardiovascular disease and mortality beyond glycosylated hemoglobin and fasting glucose. Variability in glycemic response undermines the universal glycemic index concept. Influencing factors: insulin resistance, beta cell function, ethnicity, and microbiome. Personalized profiling is crucial for targeted interventions in metabolic health. The study cohort comprised of 55 individuals aged mean age of 55 plus or minus 11.9 years. Body mass index was around 25. I guess it's the Californian body mass index. 26 were euglycemic, 26 were pre-diabetic, 1 had type 2 diabetes, 37 were Caucasian, 13 Asian, 4 Hispanic, and 1 mixed participant. 7 carb meals, 50 grams each, of rice, bread, potatoes, pasta, beans, grapes, mixed berries were tested in duplicates. Mitigators used were fiber, pea, protein, egg white, for fat, cream, and consumed 10 minutes before rise. Continuous glucose monitoring data: 848 meals, 33,920 glucose data points were paired with lipidomics, proteomics, and microbiome. Metabolic phenotyping: steady state plasma glucose, insulin resistance, disposition index for beta cell function were assessed. The carb response types: the spikers. Individuals were classified based on which carb meal elicited the highest glucose spike. Rice spikers, there were 35%, more common in Asian participants. Highest average postprandial glycemic response overall. Potato spikers showed the highest insulin resistance and beta cell dysfunction. Bread spikers had higher systolic and diastolic blood pressure, elevated N1 methyladenosine. The grape spikers were insulin sensitive, lower steady state plasma glucose and fasting glucose. Pasta spikers were rare, associated with moderate glycemic responses. Bean and mixed berry spikers not observed, likely due to high fiber and protein content and low postprandial glycemic response. Key findings: white rice produced the highest average postprandial glycemic response among all carbohydrate meals. Beans and mixed berries produced the lowest response due to high fiber and protein content. Individuals with the strongest glycemic response to potatoes had elevated insulin resistance and impaired pancreatic beta cell function. Grape spikers had significantly lower insulin resistance and fasting blood glucose levels. Bread spikers exhibited higher blood pressure and elevated N-methyladenosine, a metabolite linked to hypertension. Preloading with mitigators reduced glycemic responses significantly in insulin-sensitive but minimal or no effect in insulin-resistant individuals. Microbiome species such as Klebsiella and Satarella were associated with improved response to mitigators. Multiomics analysis revealed specific lipid and metabolite signatures. Potato spikers had elevated triacylglycerols, the triglycerides, and fatty acid. Grape spikers had more favorable lipid profiles. The potato to grape glycemic ratio was a strong indicator of insulin resistance. The limitation of the study was a modest sample size, 55 individuals, limited ethnic representation, and short-term follow-up without long-term clinical outcomes. Takeaways: 1 carb doesn't fit all. Continuous glucose monitoring plus omics stratifies individuals into spikers, Metabolic signatures align with postprandial glycemic responses. Insulin resistance plus beta cell dysfunction was equivalent to exaggerated postprandial glycemic response to starchy meals. Mitigators were less effective. Asian ethnicity was associated with rice spiking. Microbiome pathways like Klebsiella correlate with postprandial glycemic response and mitigation response. Enables precision nutrition to preempt type 2 diabetes progression beyond glycemic index. Interesting study. I guess the paper I published in 1997, the effects of components of meals, carbohydrates, fat, and protein causing postprandial angina pectoris needs to be revisited given this data. If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by Master MedFacts at mastermedfacts.com.